Good morning to everyone. Honorable Vice Chancellor, respected Chief Guest, respected faculty members, dear students and my dear friends, a very warm welcome to each and every one of you today. We gathered here to celebrate National Science Day 2025 with a special lecture on how quantum science has revolutionized the modern world. This occasion is a tribute to the spirit of scientific inquiry, discovery and innovation. Now let's all stand up for Tamil Thai Valthu. To begin this special event, it is my privilege to invite our esteemed convener of this program, Dr. T. Ravimanikam Sir, Associate Professor, Department of Zoology, Faculty Person, School of Sciences, Tamil Nadu Open University, to deliver the welcome address.
Good morning to everyone. Science is a wonderful thing if one does not have to earn one's living at it. By Albert Einstein. Honorable Vice Chancellor, respected Chief Guest, respected Controller of Examination, beloved faculty members and my dear student and scholars. Once again, good morning to one and all. The National Science Day is observed annually on February 28th in India to commemorate the discovery of the Raman effect. The renowned Indian physicist Sir C.V. Raman on February 28, 1928 and he received Nobel Prize. The day serves to celebrate scientific advancement and promote scientific temper in the country. Every year, the National Science Day was conducted by the School of Science, Tamil Nadu Open University, to empower the scientific temper to young science graduate of Tamil Nadu Open University. With this juncture, I welcome you all to this special lecture on how quantum science has revolutionized the modern world, organized by the School of Science, Tamil Nadu Open University on the occasion of National Science Day celebration 2025. Science has always been a beacon of progress, and today we gather to celebrate its incredible impact on our lives. This occasion provides us an opportunity to reflect on scientific advancement that shape our world and inspire future generation to push the boundaries of knowledge. I am truly privileged to have with us and welcome Professor S. Arumugam, Vice Chancellor, Tamil Nadu Open University, whose leadership continue to guide this institution towards excellence. He is a renowned scientist, notable scientist, overseas scientist in high pressure technology. He is established Center for High Pressure Technology in Bharathidasan University. Once again, I welcome you, sir. A special welcome to Professor G.R. Senthil Kumar, a registrar of our university. He is not available here because of official work. Next, I welcome our controller, Madam Dr. Uma Mageshwari. Welcome you, ma'am. Next, I welcome our chief guest, Professor Ganapathy Bhaskaran from IIT Madras, Department of Physics, a distinguished scholar and inspiration to many of the field of quantum science. His insight and expertise will undoubtedly enlightening, has a profound impact on quantum science, on modern technology and innovation. He is a simple and humble personality. Once again, I welcome you, sir. I also extend my heartfelt greetings to our esteemed chairpersons and faculty members of School of Science, Dr. K. Kottarajan, Dr. E. Kumar, Dr. S. Vinod Khanna, Dr. P. Sanmugavelan, Dr. R. Pragadiswari, and I also welcome Dr. Sayon, sir, other dignitary from outside. I am also welcome you, and I welcome the guest faculties, students and the participants for this gracious occasion. Thank you very much.
Next, I invite Honorable Vice Chancellor. Thank you, sir, for your warm and inspiring words that have set the perfect tone for today's event. I invite Honorable Vice Chancellor, Professor S. Armugam, sir, Tamil Nadu Open University, to honor the chief guest, Professor Ganapathy Bhaskaran, sir, Department of Physics, IIT Madras. Thank you, sir, for honoring the chief guest. Now it's time for the inaugural address by none other than our Honorable Vice Chancellor, Tamil Nadu Open University, Professor S. Armugam, sir. We are privileged to have you with us and we look forward to our words of wisdom.
அனைவருக்கும் எனது அன்பான காலை வணக்கம். மதிப்பிற்குரிய பேராசிரியர் பாஸ்கரன், கணபதி பாஸ்கரன் அவர்கள் இந்த சயின்ஸ் டேக்காக நாம் அழைக்கப்பட்டிருக்கிறோம். அவரையும் நம்முடைய தேர்வு கட்டுப்பாட்டு அலுவலர் மேடம் அவர்களையும் டாக்டர் அபிமானிக்கம் அவர்களையும் நமது கல்லூரியில் நமது பல்கலைக்கழகத்தில் இருக்கும் பேராசிரியர் பெருமக்களையும் மாணவர்களையும் அனைவரையும் மற்ற நண்பர்களையும் நான் அன்புடன் காலையில் உங்களை வணங்குகிறேன். இவரை அழைப்பது புரொஃபசர் பேராசிரியர் கணபதி பாஸ்கரன் என்பது உலகத்தில் இருக்கின்ற அத்தனை இயற்பியல் வல்லுநர்களுக்கும் ஒரு தெரிந்த ஒரு மாமனிதர். அவரை இங்கு அழைக்க வேண்டும் என்பது என்னுடைய கனவு. ஏனென்றால் இந்த ஆண்டு அவர் வர முடியாமல் போக விடுமோ என்ற பயம் கூட எனக்கு இருந்தது. ஏனென்றால் அவ்வளவு இந்த ரிட்டையரான 16 ஆண்டுகளுக்கு பிறகும் எறும்பின் சுறுசுறுப்பை விட வேகமாக இந்த உலகத்தில் இந்த ஆராய்ச்சிக்காக இயற்பியல் துறையின் வளர்ச்சிக்காக ஒருவர் ஓடிக்கொண்டே இருக்கிறார், உறங்காமல் ஒழித்து கொண்டே இருக்கிறார் என்றால் அவர் பேராசிரியர் கணபதி பாஸ்கரன் அவர்கள்தான். அப்படிப்பட்ட இந்தியா மட்டுமல்ல, ஒரு வருடத்திற்கு எத்தனை முறை அவர் உலகம் சுற்றுகிறார் என்று தெரியாது. அவர் உலகம் அவருடைய காலடியில் என்று சொல்லலாம். அந்த அளவுக்கு பறந்து கொண்டே இருப்பார். அவருடைய சேவை இந்தியாவினுடைய மூளை முடுக்கெல்லாம். அவர் மதுரையிலே பிறந்து ஒரு சாதாரண குடும்பத்தில், மிக மிக ஒரு எளிமையான குடும்பத்தில் பிறந்து மதுரையில் வளர்ந்து அவர் அமெரிக்கன் கல்லூரி மற்றும் தியாகராஜா கல்லூரி படித்து இந்தியன் இன்ஸ்டியூட் ஆஃப் சயின்ஸில் அவர் பிஹெச்டி படித்து தியரிட்டிக்கல் ஃபிசிக்ஸில் படித்தவர் மற்றும் இஸ் எ டிஸ்டிங்விஷ்டு visiting research chair at the Premier Institute of Theoretical Physics in Waterloo, Canada. Recently became a distinguished professor at Indian Institute of Technology, Madras. இவர் ரிட்டையர் ஆகும் வரை இந்தியன் இன்ஸ்டியூட் ஆஃப் மேத்தமெட்டிக்கல் சயின்ஸில் பணிபுரிந்தவர். தற்போது ஐஐடியில் டிஸ்டிங்விஷ்டு ப்ரொஃபஸராக பணியாற்றி வருகிறார். இவர் 87-88 பிடபிள்யூ ஆண்டர்சன் பிரின்ஸ்டன் யூனிவர்சிட்டி மூலம் ரெசனேட் வாலன்ஸ் பேண்ட் தியரி, ஆர்விபி தியரி என்று சொல்லுவார்கள், அந்த தியரியை உருவாக்கிய பெருமை இவருக்கு உண்டு. சூப்பர் கண்டக்டிவிட்டி என்ற அந்த சூப்பர் கண்டக்டிவிட்டியில் ஸ்ட்ராங்லி கார்லேட்டட் மெட்டீரியல்ஸ் ஓர் எனி நேனோ மெட்டீரியல்ஸ் அந்த மாதிரியான எந்த விதமான நீங்கள் தனிமத்தை எடுத்துக்கொண்டாலும் அதை பற்றிய அந்த தியரிட்டிக்கல் ஒர்க் என்றால் இவர் தான் முன்னிருப்பார். அதனால்தான் உலகம் முழுவதும் எந்த மெட்டீரியல், ஏன்னா இன்றைக்கி மெட்டீரியல் உலகம் நம்ம சொல்கிறோம், அந்த மெட்டீரியல் உலகத்தில் அதனுடைய மெட்டீரியலை நம்ம வந்து அப்ளிகேஷன் கொண்டு வரணும்னா அதனுடைய தியரி அது எப்படி உருவாகிறது, அந்த பர்டிகுலர் அந்த தனி பண்பு எப்படி வருகிறது என்பது தெரிய வேண்டும் என்றால் அதுக்கு நாம் அடிப்படையாக அதை புரிந்து கொள்ள வேண்டும். அதை புரிந்து கொள்வதற்கு அடிப்படையாக பல ஆராய்ச்சிகளை செய்து வெற்றிகரமாக அதை விளக்கியவர் நமது பேராசிரியர் பாஸ்கரன் அவர்கள். அவர் வந்து பட்னாகர் அவார்டு 1983 அவர் ஐசிடிபி பிரைஸ் அவார்டட் பை தி இன்டர்நேஷனல் சென்டர் ஃபார் தியரிட்டிக்கல் ஃபிசிக்ஸ், இட்டாலி. He was a member of Institute of Advanced Study in 1996 and also he is a Shanti Swarup Bhatnagar Prize by the Government of India in 1990 and 2019 he was awarded G.N. Ramachandran Award and there are many more awards. அதனால் இந்த இன்னைக்கு இருக்கிற காலகட்டத்தில் எப்போ நம்ம ரிட்டையர் ஆகிறோம் சந்தோஷமாக எங்கேயாவது உட்காருவோமான்னு பார்க்குற இந்த காலத்தில் ரிட்டையர் ஆகி 16 ஆண்டுகள் கழித்தும் மிகவும் சுறுசுறுப்பாக 24 மணி நேரமும் ஆராய்ச்சியே தனது வாழ்க்கை என்ற ஒரு பயணத்தை தொடர்ந்து கொண்டிருக்கிறார். அப்பேற்பட்ட மனிதர் நீங்கள் எந்த ஒரு காரணத்துக்காகவும் நீங்கள் அவர்கிட்ட போய் ஏதாவது ஒரு சந்தேகம், எனக்கு இதில் புரியல, நீங்கள் எந்த நேரத்தில் வேணாலும் நீங்கள் ஃபோன் பண்ணியோ இல்லை நேராகவோ வாய்ப்பு கிடைக்கும் போதெல்லாம் கேட்டிங்கன்னா உங்களுக்கு கண்டிப்பாக ஒரு தீர்வு கிடைக்கும். ஏன்னால் எங்களுடைய சென்டர் பல வள பரிமாணங்களை பெற்றிருக்கிறதுனால் இவரும் ஒரு ஆலோசகராகவும் எங்களுக்கு ஒரு ஊக்குவித்தலுக்கு எப்பொழுதும் ஒரு ஊக்கு கருவியாகவும் எங்களுக்கு என்றும் எங்களுக்கும் எங்களுடைய மாணவர்களுக்கும் எப்பொழுதுமே ஒரு அந்த ஒரு வைப்ரண்ட் கொடுக்கறதுக்கு தயங்க மாட்டார். அது வந்து என்ன சொல்கிறது, அது ஊற்றெடுத்த மாதிரி வந்துக்கிட்டே இருக்கும். இப்பேற்பட்ட விஷயங்களுக்கும் ஒரு தெளிவு கிடைக்கும். அந்த மாதிரியான ஒரு தெளிவு எந்தவித பாலிட்டிக்ஸ் அரசியல் சம்பந்தப்பட்ட எதுவுமே இல்லாமல் நம்முடைய ஆராய்ச்சி மட்டுமே குறிக்கோள், ஆராய்ச்சி மட்டும்தான் வாழ்க்கை என்று சென்று கொண்டிருப்பவர் அவர் நம்மிடம் வந்திருக்கிறார். அதனால் நான் இந்த சயின்ஸ் டேவில் என்னுடைய உரை மிகவும் அவரை பற்றிய அறிமுக உரையோடு நான் என்னுடைய உரையை முடித்துக் கொள்கிறேன். காரணம், அவர் நிறைய நேரம் பேசுவதற்கு நான் தடையாக இருக்க விரும்பவில்லை. அதனால் என் சார்பிலும் நம்முடைய பல்கலைக்கழகத்தின் சார்பிலும் அவர் இங்கு இந்த விழாவுக்கு வந்தமைக்கு நான் எனது மனதார்ந்த நன்றியை தெரிவித்துக் கொள்கிறேன். அது மட்டும் அல்லாமல் அவருடைய பணி மென்மேலும் தொடர எல்லாம் வல்ல இறைவனை அவருக்கு நல்ல நீண்ட ஆயுளும் நல்ல ஆரோக்கியமும் கொடுத்து நம்முடைய ஏனென்றால் நம்ம இப்பேற்பட்ட ஒரு மாமனிதர் இருப்பதனால்தான் நம்முடைய உலகம் முழுவதும் பாஸ்கரன் அப்படின்னா அங்கே எந்த யூனிவர்சிட்டியில் நீங்கள் எந்த உலகத்தில் எந்த மூலையில் கேட்டாலும் தெரியாமல் இருக்க முடியாது. அப்படி தெரிக்கின்ற ஒரு மாமனிதர் மேலும் மேலும் அவர் ஆரோக்கியத்துடன் அவர் நீண்ட நாள் வாழ்ந்து நம்முடைய நாட்டுக்கு அவர் பெருமை சேர்க்க வேண்டும் என்று மனதார இறைவனை உங்கள் சார்பாகவும் என் சார்பாகவும் கேட்டு வேண்டி விடைபெறுகிறேன். நன்றி, வணக்கம்.
Thank you, sir, for your inspiring speech and for leading Tamil Nadu Open University towards academic excellence. Next, I invite Controller of Examiner, Dr. Uma Mageshwari ma'am, to share her words of encouragement.
Honorable Vice Chancellor, most respected Registrar, and today's globally renowned scientist, Professor Ganapathy sir from IIT Chennai. I first of all thank our chairperson, Ravi Manikam sir, who has organized this Science Day. And it's a proud moment for Tamil Nadu University to have inducted Ganapathy sir as the chief guest, a Bhatnagar awardee, the highest award given by the UGC, and a well-renowned scientist. Sir, I register my thanks to you for accepting our offer and making this function a grand success. And Vinod Khanna sir also. So I feel it's a proud moment to be a part of the Science Day. And I read the topic such so as it is actually how quantum science has revolutionized the modern world. But I read it as how quantum science has revolutionized the modern world. Being a biologist, I just want to cite a single example how the evolution of scientific idea and temper has changed the scientific field. As we all know, dear students who are gathered here, a very good morning to all of you. We would have studied about Gregor Johann Mendel, a simple experiment on Pisum sativum. Though he was not a scientist, he was a priest in a church. Most of the scientific invention happened by accidents discovered. And he came out with a law of inheritance which made the world aware that characters are transferred from parents to offspring. And those days, the term gene was not invented, the term gene was not coined, so he couldn't come out with that term, but he told there is some factor responsible for the transfer of character from parents to offspring. The second landmark, and he is cited as the father of genetics. And second landmark in the genetics, if you take, it is in 1953, when Watson and Crick unveiled the structure of DNA, where we were able to detailedly come out with the composition of DNA. And the third step landmark happened in 1990, when the US government proudly announced the Human Genome Project. It was a 15-year project. And we came out with beautiful findings, and we were able to sequence more than 33,000 genes in the human body, and we were able to find the abnormalities in the genetic disorders. In 1990, the greatest advent in genetics happened when a successful gene therapy was conducted by Dr. William Anderson, who is a US doctor. He rectified the DNA in a child. The child was an Indian child of 4 years old. She was suffering from adenine deaminase deficiency. And the world witnessed the first gene therapy trial, which awakened the world. Even the genetic disorders could be corrected. And in this way, the evolution and revolution of science occurred. And all science, whatever the discoveries have been done, and in your future young scientists who are here, because India has lower number of Nobel laureates, we expect you children to come in future and pick up the fame of India. And instead of being Indian-born American citizen as Nobel laureates, let we Indians, because we don't concentrate on basic sciences, that is what is lacking here. So we have to concentrate and understand the concept, which will definitely move for the betterment of the mankind. So science plays a vital role in improving the life of mankind and the success of the living on this planet. I thank Ravi sir for giving me this opportunity to share a little bit idea and spark the population to develop in the field of science. Thank you.
Thank you, ma'am, for your insightful and motivating speech. Now we move to the most awaited part of the event, the special lecture on how quantum science has revolutionized the modern world. We are honored to have with us Professor Ganapathy Bhaskaran sir from Department of Physics, IIT Madras, a renowned physicist whose contributions to the field of quantum science are truly remarkable. Sir, we eagerly await your enlightening lecture.
நன்றி. எல்லோருக்கும் வணக்கம். நண்பர் and collaborator Armugam, Vice Chancellor of this esteemed university, and Controller and Dr. Ravichandran, and distinguished faculty members and friends, and the future of India. So, எல்லோருக்கும் காலை வணக்கம். நான் யோசிச்சுக்கிட்டு இருந்தேன், தமிழில் பேசலாமா ஆங்கிலத்தில் பேசலாமான்னு கலந்து பேச போகிறேன். பாருங்கள், ஏதாவது பிழை இருந்ததுன்னா சுட்டி காட்டுங்க என்ன பண்ணுறேன் அப்படின்னு. ஸோ can start that. அதாவது பிப்ரவரி 28ஆம் தேதி நேஷனல் சயின்ஸ் டே அரசாங்கம் பிரகடனம் பண்ணியிருக்காங்க. விஞ்ஞானம் நம்மளுடைய வாழ்க்கையில் எவ்வளவு முக்கியம் என்பதை நான் இன்னைக்கு பேச போகிறேன். டாக் அபவுட் ஹவ் இம்பார்ட்டன்ட். அதாவது நடிகர்கள் பாடகர்கள்லாம் கிட்ட வச்சு பழக்கம் எனக்கு வீட்டில் வச்சு பரவாயில்ல தம்பி இட்ஸ் ஓகே. ஐ வில் ட்ரை டு don't worry, I will. So today I am going to talk about how quantum science has revolutionized the modern world. Next. So on 28 December 1928, C.V. Raman announced the discovery of Raman effect, a breakthrough development in basic science, quantum physics, light matter interaction. And Government of India designated 28 February as National Day with an unique theme for every year. So this year, National Science Day Celebration 2025, the theme is Empowering Indian Youth for Global Leadership in Science and Innovation for Vikshit Bharat. That means a great India. இது கொஞ்சம் இந்த வெளிச்சத்தை குறைக்க முடியும். ஒண்டர்ஃபுல். இப்போ பெட்டர் இல்லை? இல்லைனா என் தலையே நிறைய வெளிச்சத்தை பிரதிபலித்து ரொம்ப உங்களை கண்ணை இது கூச வச்சிடும். ஓகே. C.V. Raman, as you all know, was a great scientist. I had the honor of seeing him once in my lifetime. I joined Indians of Science, Bangalore, in August 1970. And then November, one day, I was sitting and working in the library. I saw an elderly gentleman entering the library and shouting. Apparently he was hard of hearing. காது மந்தமாயிடுச்சு. சத்தம் போட்டு பேசிக்கிட்டு இருந்தார். நான் நிமிந்து பார்த்தா அவருடைய இந்த தலைப்பாயை பார்த்தோன்னா C.V. Raman நான் புரிஞ்சுக்கிட்டேன். நான் வேகமாக போய் பக்கத்தில் போய் ஏதோ புக்கு தேடுற மாதிரி அவர் பார்த்துக்கிட்டேன். That was my. Unfortunately, he passed away a few months later. He was a great man. I will tell something about him later. So next. Now, in parallel, exactly 100 years ago, Bose statistics and Bose condensation theory was born in 1924. This was a breakthrough in quantum light and quantum matter. உங்களுக்கு தெரியும் quantum ஆரம்பித்த விதம் when people try to understand black body radiation, அதாவது எரியிற கரி இருக்குல்ல, கங்கல்னு சொல்லுவோம், அதை பார்த்து அதனுடைய ஸ்பெக்ட்ரல் அனாலிசிஸ் பண்ணாத என்ன ஃப்ரீக்குவன்சியில் எவ்வளோ இன்டென்சிட்டின்னு பார்த்தா there is a curve called black body radiation curve. And that defied any understanding that people had at that time. And ஒரு பகுதி மட்டும் நமக்கு தெரிந்த பௌதிகத்தை வச்சு புரிஞ்சுக்கிடலாம், பாதிக்கு மேலே ஒன்றுமே புரியலை. ஸோ அதுதான் that was the beginning of quantum mechanics in 1900. So all our classical understanding of electromagnetic theory, kinetic theory of gases and so on did not help to understand what was seen. So light showed us the way to new quantum mechanics. Planck என்ன பண்ணாருன்னா, this is something a very important part of science. When you don't understand something, you make a hypothesis. அதாவது இப்படி இருக்கலாம் அப்படின்னு ஒரு hypothesis பண்ணிட்டு test the hypothesis. The hypothesis needs, sometimes it can be proved wrong. Very often, depending on how deeply you have thought about it, it can turn out to be right. So Planck என்ன சொன்னார்னா, ஒளி வந்து கார்பஸ்கியூல், அதாவது துகளாக வருது அப்படின்னு ஒரு ஹைபாத்திசிஸ் பண்ணி ஒரு கான்ஸ்டன்ட்டை இன்ட்ரடியூஸ் பண்ணால் இட் ஃபிட்ஸ் பியூட்டிஃபுல்லி தி வாட் இஸ் இன் எக்ஸ்பெரிமெண்ட். பட் அது எப்படி வருதுன்னு அவராலையும் பண்ண முடியலை, அவருக்கு பின்னாடி வந்தவங்களாலையும் பண்ண முடியலை. இந்த விஷயத்தை தான் போஸ்ன்றவர் ஒரு கல்லூரி ஆசிரியர் டாக்காவில் இருந்தார், கல்கத்தாவிலேருந்து போய் ஒர்க் பண்ணும்போது அவர் இந்த டெரிவேஷன் வந்து மாணவர்களுக்கு பாடம் நடத்தும் போது he was not satisfied with existing derivation. So he found by trial and error a method in which the notion of indistinguishability of particles, அதாவது இப்போ மனிதர்கள் எடுத்துக்கிட்டால் ஒவ்வொருத்தரும் வித்தியாசப்படுறோம், பட் எலக்ட்ரான் எடுத்துக்கிட்டால் ஆர் ஃபோட்டான் எடுத்துக்கிட்டால் ஒன்றுக்கு ஒன்று வித்தியாசமே கிடையாது. ஸோ இட் ஹாஸ் a very deep consequences in quantum physics. கிளாசிக்கல் மெக்கானிக்ஸில் அதுக்கு ஒன்று கான்சிக்வன்ஸ் கிடையாது, பட் குவாண்டம் ஃபிசிக்ஸில் ப்ரொஃபவுண்ட் கான்சிக்வன்ஸ் இருக்குது. அதை தான் போஸ் இண்டிகேட் பண்ணார். இண்டிகேட் பண்ணவொன்னே he was excited that he could show it without logical inconsistency and send it to Einstein. I will tell that story later. That's the beginning of how Einstein made use of it and the whole quantum theory was gone. So அதனால் UN declares 2025 as the International Year of Quantum Science and Technology. Next. Now, this has been my thing. Society at large continues to reap the benefit of quantum physics. For example, நீங்கள் ஒரு காலத்தில் வால்வ் அப்படின்னு இருந்தது இல்லையா, ரேடியோ வால்வ் இருக்கும். இட் காட் மினியேச்சரைஸ், டிரான்சிஸ்டர் வந்து இப்போ இன்னும் மினியேச்சரைஸ், நானோ எலக்ட்ரானிக்ஸ் என்னென்னமோ நடக்குது. ஸோ ஆல் த திங்ஸ் ஸ்டார்டட் வித் குவாண்டம் ஃபிசிக்ஸ். when John Bardeen, Bratton and Shockley tried to use the ideas of quantum physics and band gaps and so on to understand semiconductor action, PN junctions and so on. So quantum physics ஆழமாக அறிஞ்சிக்கிட்டு அதை அப்ளை பண்ணும்போது டிரான்சிஸ்டர் பிறந்தது. டிரான்சிஸ்டர் பிறகு உலகமே மாறிப்போச்சு. சயின்ஸ் அண்ட் டெக்னாலஜி, செமிகண்டக்டர், டிரான்சிஸ்டர், அதே மாதிரி லேசர் வந்தது, லைட் எமிட்டிங் டயோட், சோலார் எனர்ஜி ஹார்வெஸ்டிங், குவாண்டம் மெட்டீரியல், சூப்பர் கண்டக்டிவ் மேக்னட்டிசம், இப்படி வந்து மனிதனுக்கு டைரெக்டாக உபயோகப்படுத்துகிற மாதிரி. இன்னொன்று வந்து நம்மளுடைய புரிதல்கள், இயற்கையை புரிஞ்சுக்கிறது எப்படின்னா ஸ்டாண்டர்ட் மாடல் ஆஃப் எலிமெண்ட்ரி பார்ட்டிகல் ஃபிசிக்ஸ். நமக்கு தெரிஞ்சு எலக்ட்ரான் இருந்தது, பிறகு புரோட்டான் இருந்தது, பட் புரோட்டான் நியூட்ரான் இருக்குது, அது உள்ளுக்க போனால் குவார்க்னு ஒன்று இருக்குது, அது உள்ளுக்க போனால் குளூவான், என்னென்னமோ இருக்குது. அதை புரிஞ்சுக்கிறது தான் ஸ்டாண்டர்ட் மாடல். எல்லாமே started with quantum, and now we understand how the universe began, at least to some extent. ஒரு 3 billion years or 13 billion years ago universe was born in a big bang. ஒரு பெரு வெடிப்பில் பிறந்ததுன்னு இப்போ விஞ்ஞானிகள் சொல்கிறாங்க. அதுக்கு நிறைய ஆதாரங்கள் இருக்குது. இதனுடைய ஆரம்பத்தை யோசித்து பார்த்தா குவாண்டம் தான், குவாண்டம் வழியாக தான் இது வந்தது. அதே மாதிரி என்னென்னமோ குவாண்டம் கம்ப்யூட்டர்னு சொல்கிறோம். இப்போ வந்து நம்ம ஒவ்வொரு செல்ஃபோன் இஸ் லைக் அ கம்ப்யூட்டர். ஆல்ரெடி திஸ் எ பிக் ரெவல்யூஷனரி டெவலப்மெண்ட். நான் வந்து எம்எஸ்சி முடித்து ஐஏஎஸ்சி சேர்ந்த சமயத்தில் ஒரு பெரிய கம்ப்யூட்டர் ஐஏஎஸ்எல் வாங்கினாங்க, IBM 360. இப்போ அதை விட 1000 மடங்கு பெரிய கம்ப்யூட்டர் உங்கள் கையில் இருக்குது சார், கைபேசியில். அந்த அளவுக்கு முன்னேற்றங்கள் இருக்குது. இப்போ குவாண்டம் கம்ப்யூட்டர் வந்ததுன்னா இன்னும் உலகமே மாறிடும். There are many fascinating possibilities. So my message is a prudent and wise use of basic sciences and cooperation among nations முக்கியம். மனிதர்களுக்கு ஒற்றுமை, கோஆப்ரேஷன் இருந்தால் support from private initiatives can make the earth greener and habitable for all forms of life on earth. ஒருத்தருமே போட்டு போட வேண்டிய, எல்லாரும் சந்தோஷமாக இருக்கலாம், உலகமே ஒரு யூட்டோப்பியாவாக மாற வாய்ப்பு இருக்குது. எல்லாம் நம்ம கையில் தான் இருக்குது. நீங்கள் you are the future young people, so I am telling you, please cooperate and please help the world to grow and become greener. இது பாசிபிள். இது ரொம்ப முக்கியம். என்னென்னா இப்போ நம்ம நியூஸ் பார்த்தா, நியூஸ் சேனல் பார்த்தா, வைஸ் சான்சலர் முன்னு பார்த்து நியூஸ் சேனல் ஓடிக்கிட்டே இருந்தேன். நான் கண்ணை மூடிட்டேன், பயமாக இருக்குது. ஏன்னா 3 செய்தி சைமல்டேனியஸாக ஓடுது. எதை பார்க்குறதுன்னு புரியல. விவேகானந்தர்னா 8 தான் பார்ப்பார் ஒரே சமயத்தில். அது 3 செய்தி எல்லாமே நெகட்டிவ் செய்தி தான். அதனால் நான் டிவியே பார்க்குறதில்ல. ஸோ நீங்கள் டிவியெல்லாம் பார்த்தா உலகமே நாளைக்கு அழிஞ்சிரும் அப்படி இப்படிலாம் தோணுது. பட் தட்ஸ் நாட் ட்ரூ. உலகம் எப்படியும் இப்போ வந்து என்னுடைய முன்னோர்கள்லாம் 50 வயசுல இறந்து போயிட்டாங்க. இப்போ தெர் இஸ் அ ப்ரிடிக்ஷன் தட் மெனி ஆஃப் அஸ் வில் லீவ் ஃபார் 100 years. அந்த அளவுக்கு ஹெல்த் இதெல்லாம் முன்னேற்றி வருது. அதே மாதிரி குவாலிட்டி ஆஃப் லைஃப் இஸ் ஆல்சோ இம்ப்ரூவிங். ஸோ தெர் இஸ் லாட் ஆஃப் ஸ்கோப் அண்ட் எர்த் இஸ் பிகமிங் குட் பி மேட் greener provided we cooperate. சப்போஸ் இந்த கோல்டு ஃபியூஷன் ஒன்று சொல்கிறாங்க, இந்த மாதிரி ஃபியூஷன் எனர்ஜி, சோலார் எனர்ஜியெல்லாம் உபயோகப்படுத்தினா இயற்கையை அழிக்காமலே, அதாவது கடல்களை மாசுபடுத்தாமல் உலகத்தை எவ்வளவோ முன்னேற்றலாம் அப்படின்னு பாசிபிலிட்டிஸ் இருக்குது. ப்ரொவைடட் வி கோஆப்ரேட், ப்ரொவைடட் வி டோன்ட் ஃபைட் அண்ட் டெஸ்ட்ராய் அவர் செல்ஸ். ஓகே, நெக்ஸ்ட். ஓகே, நான் வந்து இன்ஸ்டியூட் ஆஃப் மேத்தமெட்டிக்கல் சயின்சஸ்ன்னு சென்னையில் இருக்கேன். ஐ டோன்ட் நோ ஹவு மெனி ஆஃப் யூ ஹர்ட் அபவுட் இன்ஸ்டியூட் ஆஃப் கையை வசத்துங்க மாணவர்கள். ஓகே, ஸோ ஐம் கிளாட் தட் சம் பீப்புள் ஹவ் ஹர்ட் அபவுட் இட். இது ஒரு சிறு ஆராய்ச்சி நிறுவனம். There are about 60 faculty members, 100 PhD students. We work on theoretical physics, pure mathematics, computer. I am retired from there. Please have a look at the website. There are interesting programs going on. They welcome students. You can use our library. If you show your ID card, you can participate in the programs. There are open houses and so on. Next. This is a beautiful, it's a just 10-acre campus, or 10-15 acre green. These are all the photographs that I took. And in fact, I was responsible for the creation of this pandal. அதாவது நாங்கள்லாம் ரூமில் உட்காந்து படிச்சுக்கணும். ஒரு தடவை சொன்னேன், நம்ம ஒரு கான்ஃபரன்ஸ் நடத்த போகிறோம், வெளியே பந்தல் போட்டு அங்கே லெக்சர் நடத்துவோம். நல்லா இப்போ வந்து அதை வந்து ஓட்டு பந்தலாக மாற்றிட்டாங்க. அதே மாதிரி நான் எடுத்த ஃபோட்டோ இதெல்லாம் அங்கே சமயத்தில் இந்த மாதிரி இந்த அதுக்கு பூக்கு பேர் என்ன, சரக்கொன்னை. சரக்கொன்னை வந்து பூத்து அப்படியே 4 மாதம் மார்ச்சில் ஆரம்பித்து ஜூன் வரைக்கும் பூத்து குலுங்கும் வீட்டுக்குள்ள. அப்போ இந்த பறவைகள்லாம் வரும். ஸோ தட்ஸ் மேத் சயின்ஸ். நெக்ஸ்ட், இது வந்து ஐஐடி மெட்ராஸ். I'm sure you have, many of you have been inside. This is a beautiful campus. Thanks to Kamaraj, apparently. Kamaraj got this beautiful campus for IIT Madras when it was given first. So he fought with the government and so on and got it. You can see deers passing. பெரிய ஆலமரங்களை பார்க்கலாம். இந்த மாதிரி ஒரு ரேர் ஸ்பீஷீஸ் ஆஃப் டியர் கால்ட் ஐ திங்க் பிளாக் பக், அதெல்லாம் பார்க்கலாம். குரங்கையும் பார்க்கலாம். இந்த ரூம்க்கெலாம் குரங்கு வரும். இப்போ ஒரு பெரிய சர்ச்சை என்னென்னா, மாணவர்கள் குரங்கை பார்த்து ப்ரொஃபஸர்கள் அப்படின்னு சொல்கிறாங்க, ப்ரொஃபஸர்கள் குரங்கை பார்த்து மாணவர்கள் அப்படின்றாங்க. என்னன்னு புரியலை எனக்கு. சரி, நீங்களா முடிவு பண்ணிக்கோங்க. ஓகே, நெக்ஸ்ட். இது வந்து ஐ எம் ஃபார்ச்சுனேட் எனஃப் டு பி அசோசியேட் வித் திஸ் இன்ஸ்டியூட் கால்ட் பெரிமீட்டர் இன்ஸ்டியூட் ஆஃப் தியரிட்டிக்கல் ஃபிசிக்ஸ் அட் வாட்டர்லூ, கனடா. அண்ட் இட்ஸ் a beautiful place where you see nature and institute coexist. Next, I'll spend some time because it's related to science. See, what I'm going to give is like a random walk. ஒரு ஏதோ இந்த நீங்கள் சென்னையோ மதுரைக்கு போனீங்கன்னா பஸ்ஸில் கூட்டிகிட்டு போவாங்க, இதான் மீனாட்சி அம்மன் கோயில், இதான் தெப்பக்குளம் அப்படின்னு காமிச்சிட்டு 6 நாள் அது மாதிரி தான் நான் பண்ண போகிறேன். பிகாஸ் ஐ ஹவ் நோ டைம் டு கோ இன் டு டீட்டெயில் அபவுட் எவ்ரி திங் மஹால் அப்படின்னு சொல்லிட்டு. ஸோ இட்ஸ் a research institute with extensive visitors program and it has about 25 distinguished research chairs. I am occupying one of the more than dozen named chairs and so on. What is special about this? It's an example of respect by a philanthropist for theoretical physics, open-ended research and science as something that helps transform society. This man is Mike Lazaridis. You may have heard about BlackBerry phone. Before this iPhones and BlackBerry was an important phone. He was an inventor and the company owner of that. He was a billionaire. So he wanted to become a theoretical physicist when he was young. He wanted to do quantum physics. But circumstances forced him to become only a poor guy. He became a billionaire, not a quantum physicist. So அவருக்கு மனசில் ஒரு ஆதங்கம், எப்பயாவது ஒரு வாய்ப்பு கிடைச்சா குவாண்டம் ஃபிசிக்ஸை சப்போர்ட் பண்ணணும்னு. At some point, somebody met him and he gave him nearly $140 million and said, please start the institute. So he has given nearly $500 million. So his point is, if you look at society now, the society owes to development in science in a very important way, starting from Newton, Copernicus, Maxwell, Faraday and all these people. So he says, I am giving money for a small amount of money I have. He has $8 billion. He says, 8 ரூபாயில் 1 ரூபா கொடுத்தவனு தப்பு இல்லை அப்படின்னு. அந்த ஒரு நல்ல மனசு வந்திருக்கு. கொடுத்துட்டு அண்ட் he says, please don't do useless research. நல்ல பெரிய ப்ராப்ளத்தை யூஸ் பண்ணுங்க. Don't write too many papers. Think about deep problems which will change society maybe 200 years from now, 150 years from now. அந்த மாதிரி சொல்கிறாரு. அந்த மாதிரி தாராளர்கள் நிறைய பேர் இருக்காங்க. நோபல்னு கேள்விப்பட்டிருப்பீங்க, காவ்லி. அண்ட் ஐ வில் டெல் அபவுட் மகேந்திரநாத் சர்க்கார். அந்த இந்தியாவிலேயும் நம்ம ஊர்லேயே இந்த இவர் A.C. He started this Chennai Mathematics Institute and pharma, chemistry and so on. So in fact, I had the honor of meeting him once. It was wonderful how he respects basic science and so on. Similarly, many people. And also there is this corporate social responsibility in which private people can help science and other parts of society through this corporate social responsibility. Next, please. Now, I heard this news 2 years ago. I was very fascinated. There is a famous medical college in New York called Einstein Medical College in Bronx. So, it's a very famous college, and in fact, half the students are Asian in origin, Indians, Chinese, Koreans, and so on. So, it's a very good medical college. They teach very well. One day, somebody announced that they give $1 billion, 7,000 கோடி ரூபாய் தானமாக கொடுத்தாங்க. எதுக்காகன்னா, என்னுடைய கணவர் வந்து $3 பில்லியன் விட்டுட்டு இறந்து போயிட்டார் சமீபத்தில், அதனால் நான் $1 பில்லியன் கொடுக்குறேன்னு. அது என்னாச்சுன்னா, இட் எலிமினேட்ஸ் டியூஷன் ஃபார் ஆல் த ஸ்டூடெண்ட்ஸ். ஒரு 5 வருஷம் மாணவர்களுக்கு டியூஷன் ஃபீயே கிடையாது, வெய்வர். ஸோ இந்த மாதிரியும் பண்ணியிருக்காங்க. ஸோ தெர் ஆர் fantastic things happening like this also. So my plea is, if you think about the wealth that one has, and if you contribute a little bit of money for basic science, it will be wonderful to change society. For example, in India, in Chennai, in Bangalore, there are so many billionaires. If only they think and wisely use little bit of their money for basic science, nations will progress, the world will progress, and the world will become a better place. That's my request. Next, please. Okay. About science. Now, since I'm talking to young people, விஞ்ஞானம்னா ஒரு மாதிரி நினைப்பீங்க, நம்ம போர் அடிக்கும் அப்படின்னா, but actually there is a theme behind it. So what do? You observe, make experiments, instruments, and then you look at it and conceptualize. What did Copernicus or Kepler do? They looked at some regularities in planetary motion, they made some law. Newton looked at these things, Galileo, they brought Newton's laws. And then they gave it to the hands of mathematics, mathematical tools. Then together, technology also developed. So it's a cooperative development of science, technology, mathematics and so on. That is science. Next, please.
Hello.
I want to give this particular example to impress upon you how important mathematics is and basic science is in society. Nearly 100 years or 250 years ago, there were understanding of electricity and magnetism independently. There was Gauss's law, and there was Faraday's law, Ampere's law, Boyer's law, and so on. It was James Clerk Maxwell who said there should be some connecting thread between this. So what he did, he formulated it mathematically using what was known as calculus at that time. And he formulated it, combined the four, and got a differential equation which is called Maxwell's equation. And if you look at that equation, it's a linear equation which tells you about propagating waves, possibility of propagating waves with wavelength going from 0 to infinite size. And all these waves travel with the same velocity. And when he put the permittivity of free space and other quantities by experimental observation, he was shocked to find that speed is the speed of light, known at that time. Imagine somebody working with a bar magnet and a wire carrying current, and measuring the magnetic field, wire carrying current and so on, finding some waves propagating in free space, which is to do with the velocity of light. And nobody thought that light is anything to do with electromagnetic waves at that time. So even apparently, Faraday did not believe this theory of Maxwell. So it took 20 years for Hertz to show experimentally that electromagnetic radiation is possible. Then 20 years later, J.C. Bose and Marconi propagated electromagnetic wave for communication purpose. Now the world is different. So the world has become different. Humanity got completely unified in spite of wars. We are having wars, of course, it's very bad, but we are more united than ever before. We are able to go to America, we are able to go to people from Australia, come here and so on. So the world is a big family. Of course, we are fighting among ourselves, but it's a big family. It never happened before because of this fantastic development in electromagnetic theory that was done by Maxwell in 1960 or so. It's amazing how mathematics, together with observations and experiments, can make the world a very different place. Next. Okay. So this is I'm sorry, I'm doing a random walk. So this is the story behind Raman's discovery of Raman effect. There was a doctor by name Mahendra Lal Sarkar. I wish there are many doctors like that in Chennai. He was interested in science. So what did he do? He is a scientist. He bought an old building, some dilapidated building, and started a science club. The idea was he will collect people and invite some visiting scientists also and ask them to tell about give popular lecture about science and make people feel importance of science. That he was doing. And in those period, C.V. Raman, after doing his studies, joined Calcutta as an accountant general. It's like an IAS position, very big position in those days with fat salary. So he was passing by this building one day during his regular walk in 1907. Then he went inside and said that, what is this? They said it's a science club. Then he said, I am interested in science even though I am an accountant general. Can I use your office space for doing some experiment? He said, please. So Mahendra Lal Sarkar is supposed to hand over the key to him. Here is the key. You are responsible for the entire place. So that's how Raman started in a very humble way. He made instruments, bought instruments, and started, and it ended up in Raman, what is called Raman effect. So Raman conducted a variety of science experiments in IASCS building, working part-time during 1907 to 1933. Raman effect was discovered in 1927. So in about 20 years, he made enormous progress. He collected lots of good people, students and so on. Then later he became a Palit professor and so on. In fact, that's also a fascinating thing. At that time, the salary of a British employer like accountant general was 10 or 20 times more than a professor's salary. So he gave up his accountant general post and became a professor in Calcutta University at 1/10 of the cost. Then he got Nobel Prize and so on. Next. So this is a paper. I encourage you to read this paper. You can download it freely from the internet. By the way, this paper is co-authored with great K.S. Krishnan. K.S. Krishnan was from Vatrayapur, not near Srivilliputtur. Great man. He studied in Madurai American College, intermediate. He joined Christian College and became so then he became a professor, he was a tutor in Christian College. Then when he met Raman, he joined him for PhD. And then he was a very studious, this young man. Raman was after Raman effect he knew that it was going to happen, but he worked very hard. Young Krishnan was really a great help, so they discovered it together. The Nobel Committee gave it to Raman, the Nobel Prize to Raman alone, not because Krishnan was any smaller, because Krishnan was a new person, and the original idea was due to Raman, and he has been pursuing it for a long time. And Krishnan on his own became a great scientist. I will tell briefly later about him. Next, please. Okay. Now, Raman discovered an effect. You remember, please recall the effect. Basically, light is in the form of quanta, like the old idea of Newton corpuscle nature of light, not a wave nature. So the quanta carries some energy. When that quanta enters a solid, sometimes it loses its energy, it becomes smaller in energy or larger in energy, either absorbs or emits. So, and it also does it in a way that characterizes the medium, like if it hits a diatomic molecule, it absorbs some radiation, some vibrational quanta, and then comes out, or emits a vibrational quanta and comes out. So, the quantized nature of electromagnetic radiation and quantized nature of vibrations came out very clearly through Raman effect. So now Raman effect is used as a very important probe to understand. If you go to any lab in Chennai, any lab, chemistry lab or biology lab or physics lab, there will be Raman spectrometer. So initiate the various inelastic spectroscopies, industrial applications, Raman laser, supercontinuum, discovery of quantized angular momentum of photon and so on, many things. And also supposed to be useful for understanding even future quantum computers. Okay. Now since I mentioned K.S. Krishnan, who along with Raman found the Raman effect, he has done on his own many things, magnetic susceptibility transition, Jahn-Teller effect and so on. In fact, some of you may be interested in knowing about K.S. Krishnan more. There is a special issue of Current Science which happened in 1998, 100th year, in which I am supposed to be the guest editor, where very beautiful articles are written about K.S. Krishnan and his work, how he was a forerunner of many things that are later discovered. Like many of you may know something called the Shannon formula in information theory. K.S. Krishnan discovered it. Similarly, there is something called the Krishnan-Bhatia formula, which later became Kubo formula and so on. So he was far ahead of his time and did many wonderful things. Next. Okay. So this is about the beginning of quantum. So, see, when in India, when somebody appears in a stamp, then they become really great, right? So here you see Bose in the stamp and Einstein in the stamp. And what happened was, Bose found the derivation of Bose-Einstein statistics, Bose statistics in his own way, wherein he introduced the notion of indistinguishability, which played a very important role in the development of quantum mechanics and bringing out the wave nature of particles and so on. So he found it and sent an article to the Einstein for favor of publication in translation and publication in German. Now, when they did it, he wrote politely saying that, "Sir, I have, along with Saha, I have translated your book on generality of relativity from Germany to English, and here is a copy." So Einstein was very impressed, and he went deep into the paper and was found it is true, and it's going to revolutionize quantum physics, so he got it published. That's the beginning of Bose-Einstein statistics. Next, please. Next. Okay. So science has performed miracles. Next. Yeah, next. Okay. So now I have just put it here. Yes, the universe is quantum. Like if you look at anything, if you take nebulae, lights coming from there is quantum mechanical. Many of these phenomena that happens is quantum mechanical. If you look at the beginning of the universe, so-called black body radiation, I will show later, 3-degree black body, it's a quantum phenomena. So from the beginning of the universe, quantum mechanics has been looking at us constantly. So galaxy formation, star formation. If you look at sun, if you look at the sun, as you all know, in sun what is going on? There is fusion. Hydrogen fusion, which is what is releasing energy. So sun is a big nuclear reactor, a fusion reactor, sending us constant, and that's a quantum phenomena. There is quantum mechanical tunneling, and there is a quantum mechanical phenomena. Many things are happening. So when you look at the sun, you are looking at a quantum phenomena. Our atmosphere, stones, minerals, magnets, living systems. Madam told about living system. There is so much quantum in biology. There is a whole field of quantum biology exploding. So ecosystem. So solids, liquids, nanoscience, there are experts here. Molecules, atoms, proton, neutron. So everything, even though we take for granted and we use classical mechanics to understand, classical electrodynamics to understand various phenomena, but if you go a little deeper, there is quantum lurking behind. So that's what is governing the world. So that's what I try to say. Under Sararasarathai kalki kondirikkirathu quantum enbadu. Next. And also it's amazing. So in India we have Bose, Raman, Saha, Chandrasekhar, K.S. Krishnan, who personified various aspects of quantum physics. And Chandrasekhar is very special. Since I am talking to young people, I will tell this story. Young Chandrasekhar was a student at Presidency College doing his BSc. There was Sommerfeld, a great person, a great teacher, and he discovered many things in quantum mechanics. He gave a series of lectures before he went to Calcutta at Presidency College. Young Chandrasekhar took notes and tried to understand what was taught. He understood the notion of Fermi surface, Pauli pressure, and so on as a BSc student. Then after Sommerfeld left, he applied it to the stability of stars, how stars are collapsing constantly because of gravitational pull, but then there is a Pauli pressure which is, so there is a fight constantly going on. If somebody loses, it becomes a black hole and so on. That's a Chandrasekhar's mass limit. It's a consequence of quantum phenomena that Madras got the fame, Chandrasekhar's mass limit black hole. Similarly, if you look at astrophysics, the cameras that you have, they are all connected to quantum phenomena. Similarly, many things. Next. Now, if you look at the way quantum mechanics was discovered, they say it's one of the greatest creative act of human. We all talk about literature and great artists and so on in this world. But we also should remember how intuition and what is valued in arts and so on as intuition and conceptualizations and so on plays a very important role. So next, please. So if you look at the history of quantum mechanics, these are all the Planck made a hypothesis about Planck's quanta. Then Einstein showed that photoelectric effect can be explained, that is, light impinges on a metal and it ejects an electron when the frequency exceeds some value. This can be only explained if you use the notion of quanta of photon. Einstein did that. Then Niels Bohr came up with this beautiful idea of Bohr atom model. All guesswork, conjecture, hypothesis based on some experimental phenomena. And then S. N. Bose came up with his hypothesis and so on. So it's a collective effect, unique in human history, a forerunner to the collective character of modern science. If you look at the people, Planck is a German, Einstein is a German, Niels Bohr, Copenhagen, S.N. Bose from Calcutta, De Broglie, Raman is from Chennai, and all different. It was a new collective effort. The world never collaborated so much before. As an example, you may all have heard about Large Hadron Collider at Geneva. You may have heard about discovery of Higgs particle some years ago, a boson that gives rise to masses to all elementary particles. That's called Large Hadron Collider, LHT, where they accelerate charged particles to great velocity and make them collide and look at the outcome. That gives you what's going on inside nucleus, electrons, and so on. So there are about 7,000 people working there at a given time. There are about 100 or 50, 80 countries. So never humanity have collaborated so much to discover the laws of nature and push humanity further and so on. Next. Okay, this is what light and lights. Kangal next. So this is the famous Bose distribution. Next. So I said that the quantum mechanics is there right at the beginning. This is supposed to be the black body radiation that if you look at the distant sky in the night time, coming from the Big Bang, that is few thousand years after the beginning of the universe, when there was some phenomena took place, and that light has taken so much year to reach us, and it's still obeying Planck's law. So that's so if you look at the distant sky, and of course you can't see it visibly because the frequency range is very small beyond our but radars can detect it. So that's what is going on. And the battery is there. The battery phone we don't use your willpower. Thanks. Very good. So this is the next. 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 Okay. If we take the this is again a fascinating thing. Bose discovered what is called identical particle. It was Paul Dirac, the great physicist, who gave the name boson because he said Bose's work is so important. There are a family of particles which obey Bose statistics, they call bosons. There are a family of particles which obey Fermi statistics called fermions. So it was Dirac who coined that name. And there are beautiful stories about it. I can tell you if there is question later. And then now bosons have become so important, there is something called boson sampling, which may change the world now in terms of quantum computing. Similarly, Higgs boson, the one that gives masses to every particle, quark, and electron and everything, that's called the universal mass principle. So there is something called Bose-Einstein condensation, superfluidity, many things have happened just from this simple, beautiful conjecture from Bose about identical particle character and so on. Next. This I already said. Next. Next. Okay. So when you go to see, when we see the world around us, we use classical mechanics. Like if I fall down, I will fall with some velocity, I will break my bone and so on. This is classical phenomena. But however, if you go to the level of atoms and molecules, many surprising things happen. For example, there is a phenomena in which, if I put it crudely, I can be here and also I can be outside the room simultaneously. That's called linear superposition. That's possible in quantum mechanics. At the level of electrons and protons, it's constantly happening. So Newton's laws give way to laws of quantum mechanics, and particles start behaving like wave, and then there is something called tunneling. That is, with some probability, I can go through the wall without breaking the wall and be on the other side. But of course, the probability is very small. Whereas it's easy for an electron to do that in a cavity. So quantum phenomena is very counterintuitive. We don't understand it in the normal language, but it's happening thanks to experiments and hypotheses and so on. So most quantum phenomena defy common sense and our classical intuition. This is a very important point to be noted. Next please. Okay, since we are in Chennai, there are three great quantum mechanics, my friends. Professor V. Balakrishnan, I am sure many of you have heard of him. He is a famous quantum mechanics teacher. He retired as a professor at IIT Madras. His lectures on quantum mechanics are so popular, somebody said that Tamil Nadu largest hit கொலவெறி படம் தான் ஃபர்ஸ்ட் ஹிட், அதுக்கடுத்து பாலகிருஷ்ணன் அப்படின்னாங்க. கொலவெறி பாட்டு தெரியுமில்ல உங்களுக்கு? அதுக்கடுத்து பாலகிருஷ்ணன் ஹிட், அவ்வளோ பாப்புலர் அவர். அதே மாதிரி ஏல் சங்கர்னு ஒருத்தர் இருக்கார். ஹீ டிட் அ பிடெக் எலக்ட்ரிக்கல் இன்ஜினியரிங் ஃப்ரம் IIT Madras. And then he went to Berkeley, did a PhD in physics. He is a great quantum mechanics teacher. You can listen to his talks also. Next door, University of Madras, my former colleague, senior Professor Matthews and Venkatesan, they are also great quantum mechanics. They have written books on it, beautiful book. And Professor G. Rajasekharan, there are many able quantum mechanics in Chennai now. If you go to IIT Madras or Math Science or Madras University, for example, if you go to Department of Theoretical Physics, Rita John, she is a quantum mechanics. She does electronic structure calculations and nanosystems and variety of people, quantum activity in Chennai. Next. And also, I want to say that quantum may look scary because it's counterintuitive, but it's very user-friendly. I will tell about it. For example, 3 people who became very famous using quantum mechanics. One is Peter Shor from MIT. He's an electrical engineer. Then Love Grover. I have met all the 3 of them. He wrote Grover, he's an electrical engineer. And Umesh Vajrani, who is at Berkeley, he also is an electrical engineer. What I'm saying is, in order to understand quantum mechanics, in order to become a great quantum physicist, it's not necessary you should have physics background. Because next, please. Next. So to become an expert in some aspects of quantum mechanics, one need not know all of quantum mechanics. Quantum mechanics has grown into a wild forest of God. Next. Yeah, okay. You all know Richard Feynman, famous physicist. He has 3 volumes called Feynman. I encourage you to read those books. In fact, R. Shankar read those books along with a friend that when he was a student at IIT Madras. And then that changed him and he became a distinguished physicist. From electrical engineering, he went into, became a famous physicist, world famous physicist because of reading Feynman's lectures. So Feynman's lectures are wonderful 3 volumes. In fact, they are available in Indian edition with beautiful problem set and by Balakrishnan and so on. So he says, I think I can, let me come to second paragraph directly. I think I can safely say that nobody understands quantum mechanics. So do not take the lecture too seriously, feeling that you really do not have to understand in terms of some model what I'm going to do, but just relax and enjoy it. So enjoy quantum mechanics. According to my friend Rajaya Simon, who is my colleague at Math Science, was my colleague, he says, if you know 2x2 matrix multiplication, you know all of quantum mechanics because you can illustrate all the basic phenomena in quantum mechanics using 2x2 matrix, direct products and so on. So it's a mathematics that's key to reveal the physics of what's going on at the level of atoms and molecules. So, okay. Next please. And also there's a famous mathematician, Varadan, from Courant Institute. So for those of you who love mathematics, modern quantum mechanics, many-body theory, field theory, etc. support a wonderful world of modern mathematics. Further, modern physics has helped emergence of this new mathematics. So quantum mechanics not only has used mathematics, it has also created new mathematics. Quantum physics can be entry point into rich world of mathematics. Some of you want to become a great mathematician. According to Varadan, you can do it through quantum mechanics. Over the years, the mathematics of quantum science has become more abstract and consequently simpler. That's what a mathematician says. Okay, next. Since I'm talking about science, science is like one of the key pillars of the quantum mechanics or science. Mathematics is a key pillar of science. So, for example, Wigner, a famous Nobel laureate, he has written an article saying unusual effectiveness of mathematics in science, because if you look at the development of science and physics and quantum mechanics, mathematics has become, it was developed independently by a group of mathematicians. It has given a helping hand to understand the world. So he has written a beautiful article, Unusual Effectiveness of Mathematics in Science. If you do a Google search, you will get this article. I encourage you to read it. Also, my former collaborator, Phil Anderson, he has written Unusual Effectiveness of Physics in Creating New Mathematics. That's also there. Yes, next, please. Now, this in one transparency, I'm trying to describe all of quantum mechanics. Just, in classical mechanics, you talk about position and velocity. Like if you talk about planetary motion, you say it's at this position in space and at this velocity. The rest is governed by Newton's laws and so on. So if you have n particles, then you say there is 6 n-dimensional configuration space, because phase space is like has position and velocity. So velocity is 3 component, position is 3 component 6. So if there are n particles, n dimension. Now, what happens is when you come to quantum mechanics, you say there is a probability for the system being in one of the point in this n-dimensional configuration. So suddenly you jump from points to functions. So it becomes function space. So that's a big, big jump. So in terms of size of Hilbert space and so on, it's a big jump. I will not go in detail. Next level. Next. Okay. So I'm just giving you a random walk. If I'm standing on this floor, I'm not falling through. That's because of quantum mechanics. Quantum mechanics stability. For example, if you take 2 helium atoms and make them collide, they will not go through each other at low energies. Because when they come close by, there is something called Pauli repulsion between electrons. Because 2 electrons will not be in the same quantum state. That's according to Pauli principle. So they cannot go through, so they avoid it. So the simple repulsion between atoms and molecules, and also van der Waals force is all quantum mechanical. That's why matter is what we see is stable. So stability of atom and stability of floor and so on. So quantum matter, crystals, phonons, wonderful things are happening. Everything is guesswork. For example, I will tell a little later about Fermi and so on. Next, please. Okay. Now again, I am coming back to science has performed miracle. The miracle of radio communication, the miracle of material science, the miracle of information technologies, IT. We are all enjoying it. A new discovery in solar energy can put the world in the right path to eliminate climate change catastrophe. A new discovery in genetic engineering can make us angels. Madam was telling about genetic engineering. So a new discovery we may all become angels. Quantum computers, room temperature, superconductivity, and so on. It's all possibilities. Provided we cooperate, we can achieve that. Next, please. By the way, how much time do I have? I should keep track of. No, பசங்களுக்கு பசிக்கும் பாவம். I will, okay, 12 தான் அது. See, Vice Chancellor ஈஸியாக சொல்லிடுறாரு 12 தான் பாவம் சின்ன பசங்களுக்கு பசிக்கும். Okay. So, solar power is the most promising renewable energy sources, fields of gold. How have we learned about solar power? New developments thanks to biology. Next. If you take a plant, a leaf, the அவ்வளவு efficient photosynthesis நடக்குது 100%. Every photon that falls, it gets basically accommodated. It gets converted, it creates an electron transfer reaction, water splitting, and so on. Similarly, if you take a bacteria that's living in a muddy water, that also lives on photosynthesis, some of these bacteria. So, and if you look at the phenomena, energy flow within bacterial antenna proteins and funneling, this is all quantum mechanics. This is an amazing thing. At room temperature, we don't realize that if I hold a plant or a flower in my hand, the photosynthesis that's going on is quantum mechanical. And this is a discovery which took place about 20 years ago. People thought light gets absorbed somehow and then it propagates. But it propagates like a quantum wave. So the quantum mechanics that we learn is useful for botanists. In fact, there's a famous Indian Govindji at Urbana, Champaign. He did wonderful work on quantum phenomena in biology, in photosynthesis and so on. So, nature is operating using solar energy because how Earth has evolved, light comes and it falls on materials and then it gets absorbed and something happens, and finally we are here with photosynthesis. So energy flow within bacterial antenna proteins and funneling to, next please. Now look at the change. Once upon a time I remember when I was a boy in Madurai, my uncle got a radio which had a wall. So I used to enjoy that. Then slowly it became transistor. Now we have cell phones. So from vacuum we went to semiconductor diode, semiconductor transistor, field effect transistor, magnetic tunnel junction. And next. Okay. So these people are responsible for the modern revolution in semiconductor technology. The first three, Shockley, Bodin, and Breton. Bodin is a quantum physicist, well-known quantum. He got 2 Nobel Prize. One was for discovery of transistor, another for discovery of superconductivity, BCS theory. Bodin, Cooper, and Schrieffer theory. So, what did they use? They said that electrons behave like a wave in a solid, and they form plane waves, and they use Pauli principle, respect Pauli principle, then they are filled up to some band edge, and then after there is a gap and so on. So, used elementary quantum principle in an approximate way and discovered transistor. So, quantum mechanics play a key role in, because Bodin was a key person in the development. Then others developed it. Now the world is what it is. I should tell a story now. John Bardeen is a double-time Nobel laureate. He visited Bangalore and Chennai in 1976. At that time, I was just a postdoc at Bangalore. I submitted my thesis. I was there. So John Bardeen is a man of few words. So pesave matter. So professors were telling him enthusiastically about what they were doing. He just kept quiet and nodded his head. They didn't know how to handle him after some time. Then they thought they should hand him over to the theory group. Fortunately, that day my professors were away. My Professor K. P. Sinha and Narendra Kumar, they were away. So I was the senior most theoretical physics student. So they dumped John Bardeen on me. I didn't know how to handle him. So I started telling about what I was doing. Then you will see that John Bardeen got excited and talking to me for 2 hours. So professors were very envious of me and jealous of me. They said, எப்படா நீ என்னடா உனக்கு உன்ட்ட மட்டும் பேசுகிற எங்களை ஒன்றுமே பேசலை எனக்கு தெரியல சார் அப்படின்னு சொன்னேன். Then another thing happened. 1987, I was invited to Urbana-Champaign, where John Bardeen is a professor, to give a colloquium on resonating valence bond state theory. So John Bardeen is sitting in the audience. I come out of the colloquium, people shake hands with me. I thought I gave a good colloquium. He said, you gave a normal colloquium, then why do you shake hands with me? Because you made John ask 3 questions. He never asked questions in the colloquium, so we made him ask 3 questions. So that's my experience with John Bardeen. Then he had 2 sons. Both are, one is a cosmologist, one is a high energy physicist. I have had the honor of meeting them also. And I will tell another story about eccentricity of theoretical physics. One day, Bardeen's son was telling me, one day, after getting 2 Nobel Prize, John Bardeen was very unhappy at home. He was not talking to everybody. His wife asked him, John, ஏன் இப்படி இருக்கீங்க ரொம்ப சோகமாக இருக்குங்க போடி உனக்கு என்ன தெரியும் என் பேப்பரை ரிஜெக்ட் பண்ணிட்டாங்க ஃபிசிக்கல் ரிவ்யூ லெட்டர்ஸில் அப்படின்னு 2 நோபல் பரிசு வாங்கிட்டாரு எவ்வளவோ புகழ்பெற்ற ஆள் அவருடைய பேப்பர் யாரோ ரிஜெக்ட் பண்ணால் வருத்தத்தோடு இருக்கார். தட் இஸ் வாட் தியரிட்டிக்கல் physicists are, scientists are. Anyway, next. Again, see, you all know about Voyager. You must have heard about the famous thing that was sent by NASA. It has crossed the solar system. Now Voyager is now, next please. So, it's nearly beyond 100 1000 கோடி மைல் தள்ளி இருக்கு 100 some long distance. So that now why I'm showing this is it has nuclear powered battery. It is sending messages from that distance. It takes 1 full day for the electromagnetic radiation to reach Earth with that speed. Now by the time the electromagnetic radiation reaches us, the intensity will go down like 1 hour, as you know. So we are able to detect that thanks to quantum detectors. So that's the power of quantum physics. Some 25 watts bulb, which is kept at 100 crore miles away, we are able to detect it. Basically, that's the power of quantum sensitivity. Next, please. Anyway, next. So, this is the, I encourage students to read about Voyagers. It's a beautiful phenomena. This is something that was sent in 1960s. They thought it would work for 5 years. Now it is working for 50 years. It's still sending messages. It has gone outside the solar system. It has gone to interstellar medium. There was some shutdown. Now it's working again. It's amazing how, anyway, things can happen. Next. Okay. Again, I encourage students to read this. If you do a Google search, there is plenty of room at the bottom. It's a very important paper by Feynman. Feynman was supposed to give a talk to a group of people. He was not prepared apparently. He suddenly cooked up some ideas and he spoke to them in a meeting. The idea was the following. So we are macroscopic people, we are 1 meter, 1 centimeter and so on. But if you go to the level of atoms and molecules, there is 8 orders of magnitude size reduction. 1 atom is 1 angstrom unit, 1 centimeter is about 10 raised to 8 angstrom unit and so on. So orders of magnitude reduction. So he said, can I make use of this reduced volume to do something? So he said, wrote an article called, there is plenty of room at the bottom, naming. So he said, let me take a pinhead, to count the number of atoms, they are sufficiently large to put, write Encyclopedia Britannica, 20 volumes in the same pinhead. Because we don't comprehend that when you go down 8 orders of magnitude, how many atoms are there. That's the number of atoms. Then he said, I can make motors made up of atoms and molecules. I can make use of it. He just hypothesized and generally made some speculation. And also he made a very important thing which is called, he said, why not use quantum wave nature of particle and superposition and so on to our advantage, the way that we use electricity and magnetism. That's the beginning of quantum computer. So I had again the honor of meeting Feynman once. It was 1984. I was at Princeton. We drove to Bell Labs where Feynman gave a talk. 1984, imagine, he was talking about building quantum computer. So there are something called qubits, which are basically transistors of computers. He was worried about how do they communicate. Do you put molecular wires that carry electricity, or do you put some microwave emission that is absorbed? So 84 he's a father of quantum computer and father of nanoscience. It is because of him. Next, please. Scanning tunneling, this is called electron microscope. This is ordinary microscope. Next, you have electron microscope. Instead of light wave, you send the electron wave. And now, by the way, there is a beautiful electron microscope in IIT Madras called Cryo-EM. I encourage students to visit the lab. It's run by Pradeep. So you can get permission and see fantastic thing where you can see molecules and atoms, single clusters of atoms, not periodic array, through these microscopes. So that's again due to quantum physics, electron wave interference. Next, please. Then these guys got Nobel Prize. Next. STM. This is supposed to be surface of some kind of copper metal, and all this cone that you see is an atom that is arranged in this form. So you arrange atoms and then image them using scanning tunneling microscope. That's the level of perfection that we have reached with respect to using quantum principles. Next. Similarly, cesium molecule. Next. Then you also know fantastic development in the field of nanoscience and novel materials. Carbon, கரி துகள்னு சொல்றோம் சாதாரணமா. If I remember when I was doing my SSLC, there was a lesson called கரிப்புகையில் கற்பகம். If you analyze the carbon suit, you will find pieces of diamond, you find pieces of carbon nanotubes and so on. So this has produced evolution. Many things have happened. It's the same carbon which forms a diamond, becomes fullerene, nanotube, graphite and so on. So these are allotropes. Properties are extremely different. Diamond is the best insulator, hardest material, whereas graphite is a conductor, very soft, you can peel them off and you can use it, transistors and so on. Next, please. Next, please keep going. Yeah. Next. Yeah, okay. So, I think I will finish in 10 minutes. So, one of the important discoveries in the quantum physics was what called superconductivity. It took place in 1911. Cameron once, he was trying to cool down mercury. Mercury is a liquid. When you cool below 0 degrees Celsius and so on, it becomes a solid. Then he cooled it down further. He found suddenly the resistance vanishes identically. It's not small, it vanishes identically. He called it a superconducting state. Then next, there was also somebody by name Meissner who found that in the superconducting state, the magnetic field, external magnetic field is completely expelled by the superconducting state. Like if you put a piece of superconducting material, which is a black disk, and there is a magnet below, it's all immersed in liquid nitrogen, some high temperature superconductor. It will float because it will fall down on the three pillars, but there is a force against gravity from magnetic field expulsion. So they balance and it's floating. So this is called Meissner effect. Next, what is the advantage? Something called magnetic levitated train. So Japanese have built this and now it's being used in Shanghai and so on. Magnetically levitated. Basically what you do is you use this principle to float a train without having rails. So it slides without friction. Just air friction is the only thing. And it can reach a maximum speed of 2000 kilometers per hour. 2000 kilometers. And now with, of course, at that time the things will burn. So without air friction, you can go about 500 kilometers and so on, which is being used in various places in the world now. So magnetically levitated train is a possibility of superconductivity. Next. So superconductivity is a state in which current moves without any resistance. It's a macroscopic phenomenon. I can take a ring of like lead metal, go to low temperature. If I inject a current will flow for years without getting dissipated. Normally, if you inject a current, it will decay very quickly in nanoseconds and so on. Because electron will lose its energy to lattice vibrations and radiation and so on. Here in a cooperative way, quantum mechanics comes macroscopic and it behaves at one unit. So that's now friend Kitazawa, who is no more, he had a dream. Next please. He said that I will connect the world by superconducting grid network with power transmission, so wind power and so on. He became a science minister of Japan. He estimated that if only governments cooperate, it will be 10 times cheaper than the money that we spend for energy now. Even though you put superconducting cables along with liquid nitrogen, liquefier and so on. Next. Similarly, he envisaged several other things, train. Next. In fact, Maglev, next. He said that he had his proposal was that he will connect the entire world by magnetically levitated train from one corner to another corner, and it will completely stop. You can stop aircraft carriers. So greenhouse emission can be stopped. So this was a dream of Kitazawa. Fortunately, he passed away. So when I met Kitazawa, even after the talk, I gave a conference summary talk in which I called it as Kitazawa dream. I told him that if you look carefully, the train passes through Madurai. So I was very happy because I'm from Madurai, so I can get into the train and go anywhere that I like. That was my vested interest. Next, please. Okay. So this field of superconductivity, which is called a macroscopic quantum phenomenon, has grown in started at 5 Kelvin at mercury or in lead and so on. Now sky is the limit. There are superconductors which are claimed to be at nearly room temperatures. So things have gone, like if you go to Arumugam's lab, they try to apply pressure and increase the TC and so on. So next. So I wrote a paper some years ago about new ways of creating superconductors. So this is again a small story. Some former student of mine, Fethi Madhuri from Tunisia, invited me to give a series of lectures. I told him I will come to Tunisia provided you take me to Sahara Desert, because I have seen mountains, I have seen ocean, I want to see the desert. So he took me to the desert and I am meditating or contemplating on superconductivity at room temperature. See, that's a picture in 2006. So I wrote this article thanks to P.W. Anderson, my famous collaborator, great man. I was fortunate enough to be at Princeton when this happened. So we wrote some papers and so on. So based on that, I have suggested ideas. Next. This is again something something called quantum entanglement. I think I will give an analogy. Imagine there's a husband and wife. They like each other. So if the husband is happy, wife is happy. Husband is unhappy, wife is unhappy. Suppose they separate, somebody is in Inaugural, somebody is in Pune. If husband gets hurt, it hurts the wife, or mentally. We call it telepathy, right? Something like that. So similar phenomena happens in quantum mechanics. You can take two electrons forming a spin singlet, separate them in a hydrogen molecule, for example, separate them over long distance. You find if you do something here, instantly something else happens here, as if they are communicating beyond space. So that's called quantum entanglement. This is being used in quantum computing in a very big way. Next, please. So if you take a classical computer, you will have one thing. Now quantum computer, you have next. Okay. This is just since I am running out of time. When you do a computer like yours, what you do is you find that you start with some initial state and you have a program, series of operations which will give the final result. So there's only one unique path. That's what my cell phone does. Whereas in quantum mechanics, because of the nature of quantum mechanics, something wonderful happens. Next, please. Next. What you find is, it's like it does multitude of operations simultaneously. It is exploring all the colored paths simultaneously, and then there is something called quantum interference, and then chooses the optimal thing. It's amazing phenomena. Sorry, I have no time to go into this. It's called path integral description of quantum computers. So in a very fundamental, that's why they say that even if you build a 50-qubit quantum computer with a long lifetime of qubits, it can overwhelm all the capacity of all the classical computers in the world put together now, 50 or 100. Amazing possibilities are there for you in the future. Next, please. So in the name of quantum, so many things have happened. quantum simulation, quantum algorithm, quantum annealing, quantum supremacy, and so on. And then its place there are qubits. Then there in biology also quantum is entering in a fantastic way. Electron and nuclear spins, microtubules, photosynthesis, and so on. Next. Okay. Let me complete with this. You must have heard about gravitational wave detector. Imagine two black holes running around each other and colliding and sending some gravitational wave. 2 billion years ago, the wave traverses through space 2 billion years. 1 billion rade? 6 into 10 raised to 9 years. 10 raised to 9 years is 1 billion years. So light has taken 3 times 10 raised to 9 years to travel. That's the distance light has taken. Gravitational wave also moves with the velocity of light. So, and this LIGO gravitational wave detector detected it. And if you go behind, it's the power of quantum technology which has enabled it. So that's why I'm pointing out. So I encourage students to do some good Google search on LIGO. There are fantastic sites available where you can get wonderful information. Next. Okay. So, sorry, please go to the previous one. There are quantum technology which was used in a very fundamental way at level 4 level of feedback and so on. Next. By the way, on March 7th and 8th, there is a symposium, quantum symposium for young investigators. The symposium will feature 40 invited talks. People can, register. There is no registration fee. You can see it on YouTube, or you can go personally to the place in IIT Research Park, and I welcome you to go there. Next, please. Okay. So since you're all students, I want you to realize the importance of your friends and colleagues. So group discussion is very, very important in your scientific career. Next. Do you know Einstein became what he was because of group discussion? He joined ETH for a 5-year MSc program. From day number 1, he collected like-minded people and started talking about philosophy, religion, science, everything, deeply for 3 hours every day. There was no cell phone distraction, no WhatsApp, no messages, and so on. So they went into depth, and they found a book called So they found a book which, next please. Next. Sorry, please go back. I think I missed one slide. One. Okay, next. So they found a book during the discussion which is by Henry Poincaré about unsolved problems in science. The first problem that was told was about Brownian motion. Second was photoelectric effect. Then the third was about ether. So Einstein learned about the problem during that group discussion and solved it and became great. He discovered theory of Brownian motion. He discovered photoelectric effect explanation, and he discovered spatial theory of relativity. So he owes all his discoveries to the group that he formed during his MSc days. So I encourage young people like you to form group discussion. Please don't waste your time looking at social media and so on. They are dissipating. So your inner strength can come out if you do group discussion. Next. Yeah. And then Einstein, I'm only passionately curious. I'm neither specially clever nor especially, I'm only very, very curious. The important thing is not to stop questioning. Next. It's not that I'm smart, it's just that I stay with problems longer. Next. I think and think for months and years. 99 times the conclusion is false. The 100th time I'm right. That's Einstein. When I have no special problem to occupy my mind, I like to reconstruct proofs of mathematical and physical theorems that have long been known to me. There is no purpose in this, merely to indulge in the pleasant occupation of thinking. So, avoid pleasant occupation of watching the cell phone. Please think about things. I see young people looking at the cell phone now. In fact, it happened once. There was a speaker, very distinguished speaker, giving a talk. He requested people not to watch cell phone. So halfway through his talk, he found 3-4 people watching cell phones. He politely stepped out and went away. That happened. So I'm not going to do that, but I'm finishing it. Next, please. Okay, now you have all these things. Next. read many things. Just to give you one example, Venkatraman, who got Nobel Prize in biology, if you talk to Venki, he will say he was inspired by reading Scientific American during his BSc days and Feynman's lecture. Then he became what he was. It's very important to read this popular science book and so on. Next. Okay. So science and technology and humanity has made humanity big. Never in the history of our earth there were so many human beings, about 120 crores of Indians, a big family of several hundred crores of human beings. I hope that science and technology will help make this big family into a happy family. Thank you very much. Extremely sorry, I was a long time and also not keeping the.
அறிவியல் மலர்ந்த ஸ்டூடெண்ட்ஸ்
That was an incredibly insightful and thought-provoking session. Thank you so much, Professor Ganapathy Bhaskaran sir, for sharing your knowledge and making complex quantum concepts so engaging. As we near the end of this wonderful event, it is time to express our gratitude. I now invite Dr. S. Vinod Khanna sir, Assistant Professor, Department of Botany, School of Sciences, Tamil Nadu Open University, to deliver the vote of thanks.
அறிவியல் மலர் தரேன்றாங்க வெயிட் பண்ணி சார் அறிவியல் மலர் The Arrivial Malar book available outside. It will be distributed to the student. No, 5 students are invited to.
Now 5 students are invited on the stage to receive the Arrivial Malar book. Any 2 girl students, please. Okay, now I invite Dr. S. Vinod Khanna sir, Assistant Professor, Department of Botany, School of Science, Tamil Nadu Open University, to deliver the vote of thanks.
Good morning to one and all. It is a great honor and privilege to propose the vote of thanks. I start with the words of Marie Curie. Nothing in life is to be feared. It is only to be understood. To begin with, on behalf of School of Science, I would like to thank our chief guest, Dr. Ganapathy Bhaskaran, retired professor from IIT Madras, has given an excellent speech on how quantum science has revolutionized modern technology. Who spaces his time to deliver this wonderful talk. Thank you, sir. Now I place on record our gratitude to our Honorable Vice Chancellor, Professor S. R. Mohan, for this event. Your concern and your consistent encouragement bolsters all our endeavors, sir. Thank you, sir. Next, I would like to thank our respected registrar for Professor G. R. Sindhil Kumar for his support to complete this event. Thank you, sir. And our controller of examinations, Madam Dr. Uma Maheshwari, we will thank on behalf of School of Science. My heartfelt thanks to our colleagues, our school head, Dr. Ravi Manikam, Dr. E. Kumar, Dr. Patrajan, Dr. Praveshwari, and Dr. Samuelalan, and also our fellow faculty members of different schools and heads of the divisions. And last but not least, to the students and research scholars of different schools, colleges, and universities. Thank you, one and all. Thank you.
Thank you, sir, for your heartfelt words of appreciation. With this, we conclude today's event. A big thanks to all our dignitaries, faculty members, students, and guests for making this session a grand success. May the spirit of science continue to inspire us all. Once again, wishing you all a happy National Science Day. Now let's all stand up for National Anthem. जगज्जेहि भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मागे गावे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय. Thank you.